What are quarks in physics? Quarks are fundamental particles that make up protons and neutrons, which are components of atomic nuclei. They are the building blocks of matter and are the only elementary particles that engage in all four fundamental interactions: electromagnetism, strong interaction, weak interaction, and gravitation. Quarks come in 6 flavors: up, down, charm, strange, top, and bottom. Each flavor has a distinct electric charge, mass, and spin. Quarks are never found in isolation due to a phenomenon called color confinement, which means they can only be observed within composite particles like protons and neutrons or in quark-gluon plasmas. Here are the 6 flavors of quarks. Up quark has an electric charge of plus 3/2e and is one of the lightest quarks. Down quark has an electric charge of minus 3/1e and is also one of the lightest quarks. Strange quark has an electric charge of minus 3/1e and a higher mass than the up and down quarks. Charm quark has an electric charge of plus 3/2e and is heavier than the up and down quarks. Bottom quark has an electric charge of minus 3/1e and is even heavier than the charm quark. Top quark has an electric charge of plus 2/3e and is the heaviest known quark. Matter quarks versus antimatter quarks. The primary difference between matter quarks and antimatter quarks lies in their charge and quantum numbers. Matter quarks and their corresponding antimatter quarks, antiquarks, have the same mass but opposite electric charges. For example, a quark with a charge of plus 2/3 corresponds to an antiquark with a charge of minus 2/3. Additionally, other quantum numbers like baryon number and lepton number are also opposite for matter and antimatter quarks. Quarks are fundamental particles that make up protons and neutrons, which are the building blocks of atomic nuclei. Each quark type, up, down, strange, charm, bottom, and top, has a corresponding antiquark type with the same mass but opposite charge. When a quark and its corresponding antiquark meet, they can annihilate each other, converting their mass into energy, often in the form of photons or other particles. This annihilation process is a key feature distinguishing matter quarks from antimatter quarks. In terms of quantum numbers, matter quarks have a baryon number of +1, while antimatter quarks, antiquarks, have a baryon number of -1. Similarly, leptons have a lepton number of +1, and antileptons have a lepton number of -1. These quantum numbers help physicists track the conservation of matter and antimatter in particle interactions. The asymmetry between matter and antimatter in the observable universe remains one of the great unsolved problems in physics. Experiments at particle colliders like the Large Hadron Collider, LHC, have observed subtle differences in the decay rates of certain particles and their antiparticles, which may provide clues to understanding why the universe is composed almost entirely of matter.